Hello everybody and welcome to this video on extension methods. In C#, extension methods allow you to add new methods to existing types such as classes. They can be particularly useful when you don't have access to modify the implementation of the class, such as when working with third-party libraries or system types. In this video, I'll show you how to create some extension methods. I'll be extending the int type and some collections of values as well. So extension methods must be static in themselves, and they must also be in a static class. I've got my static class here set up, um, even though they're called as if they were instant methods. But let's look at how would we create one. So if I wanted to extend the int type, I might do something like this. So this is a basic extension method. So what we're saying here is we've got our int type, which is called I, and when the user passes some parameter into this extension method, we're checking that the value is less than the integer which it's attached to. If this is the case, then it will return true. If not, it will return false. So we're extending what an integer can do by adding an additional method to it. So let's see that in action in program.cs. So what I've done here is I've defined an integer as 101, and then I've defined a variable here is less than, and as you can see, we can now attach our extension method to this integer 101, can extend it, and we're passing a value of 100. So we're checking if 100 is less than 101. We can then console.log the result. So if we run this code, we can see that we get an answer of false because 101 isn't less than 100. So you can see if we have some common functionality in our code that we want to do over and over again on something like an integer, for example, we might be able to use an extension method like this, which just allows us to directly extend from the functionality of that type. So that's what we've done here. Just got our integer, and we're using this method to basically check the value of the integer against some condition. In this case, is it less than 100? We can also extend lists and collections of values. So in this example, I'm just going to create an extension method which aims to create chunks within a list of a certain size. So the aim is when a user adds a parameter of, say, 3 or 4, it will split a list into 3 or 4 chunks. And this can then be done directly from the list as an extension method. So we could do something like this. Okay, so what we're doing here is we're defining a extension method called chunk by, and it's extending here using this keyword, the list type, and it's requiring a parameter of the chunk size. So say if we were to provide a parameter of 3, that would split the list into 3 equal parts if that was possible. We're just doing a quick check here in an if statement to make sure that the chunk size is greater than 0, because if it's not greater than 0, then we can't split up the list correctly. And then this for loop is the main functionality where we're splitting up the list. So we're iterating in the chunk size. So say if the chunk size was 3, we're iterating each time through 3 parts of the list each time. We're starting at the first position and then we finish at the size of the list. So the getRange function takes 2 parameters, the first parameter being the start of the range, and then the second parameter being how big that range is. So each time the start of the range will increment by the chunk size. So initially the start of the range will be the first element in the list, and then the start of the range will be 3 along or 4 along based on what the chunk size is. Then how big that range is going to be usually the chunk size. However, there might be a situation where we also need to check the list.count minus I to check the number of remaining elements in the list. If this is less than the chunk size, then we take this as the chunk instead. For example, if there's only one element remaining, we don't try and take the 3 items. Say if the chunk size is of size 3, but we only take the one last remaining item. So that's why we've got this little section in here as well, and the math.min. We're using yield in this scenario because it allows us to return elements one by one from a collection without needing to store the entire collection in memory. GetRange just returns a shallow copy, so it's returning references to the same elements in the list instead of a copy of that list. So let's have a look at how we could use this extension method. So here we're just defining a new list. We're defining that the chunk size should be 3, and then we're printing out the different chunks. So let's see that in action. You can see here that it's correctly split the list into chunks of size 3. And then when it's come to a situation where it can't fit in number 10 into a chunk of size 3, it's just created its own chunk for number 10 of size 1 at the end. And that's what this case was doing here, just in case the chunk size was bigger than the number of remaining elements. So let's look at one last example. In this example, we're going to be extending an enumerable collection of strings. So this will allow us to hopefully be able to extend a list of strings, an array of strings, etc. So because it's an IEnumerable, that means any collection that can be iterated over. So let's have a look at an extension method we could use for that. So in this case, I've created an extension method called capitalize, which will take an enumerable collection of strings, and it will capitalize each string, hopefully, in the collection. So this for each loop is going through each string in the collection. It's double checking that that string isn't empty. If it is, then it will just return the string. But if it isn't, then it will capitalize the first character in the string and then the rest of the string starting at the second position in the string should be lowercase. Let's have a look at that in action. So in this case, we could use a array of strings, for example. These being animals in this case, and hopefully the extension method should take all of these strings and capitalize them. So in a format where the first letter is capital and the rest are lowercase. So we'll look at that. We can see it correctly capitalizes those strings. So because this extension method works for an enumerable collection of strings, it doesn't just work for an array of strings. We could also try some other input types. So we can see it will work for a list of strings as well. And it will also work for a hash set of strings. So this was some examples of extension methods in C#. Thank you for watching.